Hello everyone, welcome to the lesson 3. We are in logarithmic function and now we will talk about common logarithms. Let's go to the learning objectives of this lesson. They are to solve exponential equations by using common log and to evaluate logarithmic expression using change of base formula. Now these are two important things we will come across. Before I tell what is common log, let's see the keyword. It's same thing, common logarithms or common log. Now, what is this common log exactly? Let me write log base 5. This is logarithmic function, but we don't call it common log. Let me write log 15. But let me write log 10. This is called common log. Why? Now, there is a history behind it. For the basic understanding, which is the easiest power? Now, say we have to take something to the power, like say for example multiples of 5 to the power 1, 5 to the power 2, 5 to the power 3. Is it easy to remember? No, it's not that easy, right? It's 5 power 1 is 5, 25, 125. It becomes crazy and crazy as it goes on. But do you know there is one easiest number that is used for scientific notations as well? The main intention is because it's very easy in terms of stacking it in terms of powers. It is basically 10 if you have guessed. 10 is an easy thing, isn't it? So 10 to the power 1, 10 to the power 0, let's start with 0, 10 to the power 1, 10 to the power 2, 10 to the power 3. It's easy to write. Why? Because 10 to the power 0 is 1, 10 to the power 1 is 10, 10 to the power 2 means you should just keep on writing one and number of zeros. If anyone asks you 10 to the power 6, it's a million, yes, but what? It's 6 zeros. That's it. It's easy, right? So now we know log and exponential are inverse of each other, isn't it? Log base 10 and say we have over here 10, okay? This is equal to what? Now it is equal to 1, but we can take the inverse. We can take this base to the other side and it becomes 10 equals 10 to the power 1. So whatever I'm writing over here can be easily translated to log. How? This will go to the base and that's it. Now, for example, if I have this problem here, this goes to the other side and becomes the base. 6 is equal to log base 10 of 1,000. Sorry, 1 million. Now, what I'm trying to say over here is it's easy with number of tens, and the answers for the log functions, log base 10 of 1 million is 6. So now they generally started using common log as 10 because this was the easiest to understand, to interpret, to calculate. Why? Because it was in regards to 10 to the powers, right? So therefore this became the common most used log, and then therefore we call it common log. Okay, because of its simplicity and everything. Now there's one more thing. If you look into your calculator, now you can see there is log base function. But if you go to the older models, there was no log where you can easily type the base. The thing is, you used to have only log. This used to be always base 10. If it's not written, log is just mentioned, then you should know it is base 10. There is something called natural log over here. ln, sorry, this one. Some call it lan, natural log, okay? Now this one, natural log, is basically log base e, which we'll study in the next lesson. So these are few things you must remember in this calculator. These three are log functions, yes, but what are they? This can be of any base. This is log, means it's already understood it's base 10. And now if you're thinking of ln, it is log base e, Euler's number. So this is basics of common logarithm. Now I hope you know why it's called common log. And over here in olden calculators it was just log function, and that's the thing. We have done the graphing already before, and now we will look into problems then. Okay, over here is something what I was trying to say, you know, this 10 to the power 0 is 1. You can easily write in log because they both are inverse of each other, right? So it is easy for us to calculate and do operations on logs. Now here they are asking you to use a calculator and evaluate log 8 to the nearest 10,000. 10,000 means how many zeros after decimal? 10,000 is so much. How many zeros are there? There are 4 zeros. So after decimal there must be 4 zeros. That's it. 10,000. See the zeros 1, 2, 3, 4. After decimal point you must have 4 decimal. Sorry. After the decimal point you must have 4 digits. Okay, I was telling zeros and decimals. It's digits what I meant to say. Now how do you find log 8? This is it. It is 0.903 and approximate the next digit to 1 because it's more than 5 over here, 8. So it becomes 1. Now let's try with log base 10. 8. It'll be the same answer. But if I change the base to anything other than 10, let me take it as 5. You will get some other answer, okay? So remember, log base 10 means log. Now let's see over here. Okay, we have a real world problem. The amount of energy E in ERGS, which is pronounced as ergs, it's basically a unit of energy, you know, like how we have length, centimeter, meter and stuff like that. Okay, E ergs that is released by an earthquake is related to Richter scale magnitude M by the equation log E equals 11.8 plus 1.5 M. Okay, E is the energy. Although the scale was created in the 1930s, earthquakes that occurred before its invention have been estimated using Richter scale. For example, an earthquake in Cyprus in almost 13th century, that is 1222, is estimated to have measured 7 on the Richter scale. How much energy was released? Now, Richter scale is something which uses logarithmic function easily, and it is used to measure earthquakes and stuff. It's a real world application. Here they are asking you to, they have given you the Richter scale value 7 and they want to know how much energy was released, because the scale according to the measurement of the earthquake, it comes on this scale of 7. Now this is the equation which is used. See over here, log E equals 11.8 1.5 M is used to find the energy, where M is basically the magnitude, Richter scale magnitude, which was 7, right? All you need to do is put this 7 over here and now simplify, add them up, you will get 22.3. Now you can directly see, you can put this directly in calculator and solve this one, or you can simplify. Now what happens over here, you know log is base 10. Take it to the other side. It will be E equals 10 to the power 22.3. That's the answer. Okay, they have simplified it. Let's put this in calculator. You'll get the answer. 10 to the power 22.3 is 1.99 into 10 to the power. Okay, it's 1.995. So it is 2 into 10 to the power 22. That's it. Or else you can even try this. See, log unknown value x equals 11.8 plus 1.5 times 7. Shift and solve will give you the answer. It'll take a long time, but the same answer. See, this is the answer. I hope this is clear. That's the thing. So the amount of energy released was approximately 2 into 10 to the power 22 ergs of energy. Now here we have another problem where we can, you know, take this log to the other side, get it in terms of, you know, base and everything and solve. Or you can just put in the calculator. Oh, sorry. Now the thing is over here, it's not taking other side. You're taking log on both the side and using the properties which we studied in the last lesson. Now here what happens? If you take log on both the sides, it's fine. Because we know whatever is inside log, provided the bases are same, can be equated. So we can take log on both the sides. Now what happens? This x is there, right? It'll come down. Why? Because that's a property of log. The power can come down, and log 11 equals log 101. X will be equal to log 101 divided by log 11. And what is the answer over here? You can use the property of log, that is subtracting these both. Okay, we had seen in the last class. Or you can just put in the calculator and you can get the answer. Say this is what I meant. Okay, we had the exact method is not done. They've just put in the calculator because log functions can be put in calculator, or you can use the method which we used last class, but you can directly use the calculator. So keep it short. Over here, you should just know that this part always can be equated, whatever is inside log, and same way you can apply log on both the sides, and you can use property this power comes down over here, and then you're taking this to the other side and simplifying it. But let's try directly in calculator. 1 second. 11 to the power x equals, sorry, it should come down over here, equals 101. Shift and solve. The answer is, let's see, yes, it's the correct answer itself. Approximated correct. Now you can even try this. Divide log 101 divided by log 11. It's the same answer. So this is how we solve this problem, and then you can check by using graphing calculator, which we do not have, but this is more than enough, the answer. Now here you have inequality. So in this case, you need to know the normal solving. How do we solve this? Take log on both the sides, and that time this powers can come down, isn't it? So basically what you do is log, I'll just write over here, log here and log here. Okay, what happens when you take log? This power comes down, so you will get 2y minus 5 log 6 is less than 3y log 5. Now these are just logs. So what you do is solve for y. Solve for y in the sense, I will keep this y over here. Okay, first of all, there is 2y minus 5, so you need to multiply this inside, like distributive property first, and then you need to simplify. You can see over here, this is done, distributive property. Why? Because I can't just directly solve for y over here, isn't it? I need to take this to the other side, but this is having a bracket. When we bring it down, there are two terms, it's not a single term. So you need to do distributive property, that is basically multiplying log inside. Okay, then it will be 2y log 6 minus 5 log 6 less than 3y log 5. All you need is this y values, so group y's together. So now leave this over here, take this to the other side. Okay, this one, minus 5 log 6 is over here, is less than 3y log 5, and take this entire thing to the other side. It becomes minus 2y log 6. Is that okay? And now you can remove y common out, because y and y is there. I'm removing y common out. You're remaining with 3 log 5 because y is gone from this, minus 2 log 6. Y is gone, so y is removed out. And over here it is minus 5 log 6. Now you can take this entire thing, divide both the sides by this part. That is divided by 3 log 5 minus 2 log 6. Put this in calculator, you will get the answer for y. That is, so basically over here, the assumption is log functions can be used by calculator. Okay, that's why. Now if you're using scientific calculator, you can even put this entirely and solve, but I'll tell you for that. Minus 5 log 6, close the bracket, divided by 3 log 5 minus 2 log, sorry, it's not cos, log 6. The answer is negative 7.1 and so on. Okay, that's the correct answer. Now here, the important thing is, it'll be minus 7.197 is less than y. But you always write y as first. In your options, you won't have this option. You will have y is greater than negative 7.197. I hope this is clear. So that's why we change it out. Now, if you're thinking, can I put this directly in calculator and get the answer? Let's try. And I'll tell you how you can. It is 2 alpha x minus 5 Instead of inequality, you need to put equal to sign and solve it. 5 to the power 3 x, because we don't have y option, we put x as unknown variable, shift and solve. The answer will be this answer itself. It'll take some time. Okay, so because it's a huge competition, okay, you got it over here, but sometimes you don't get an inequality, like, because we're dealing with powers. If the powers are huge, say powers are like in terms of a huge number, it doesn't compute it. Okay, now this, you got the answer. Okay, you got the answer directly, but now how would you know where the inequality sign lies? So for this, you need to see which is a bigger number over here. Obviously, you don't know the y value, right? Don't consider y, just see which is bigger. Okay, this is a confusing method. Now, but it is possible. This is possible, but this is like not a shortcut. It's too much to remember. Now, answer will be got. So, it is minus 7.197, right? But how is the inequality? We know that inequality, sorry, 97. We can see over here it is less, but no, y can be greater or less than. The inequality will remain same if this is bigger than this. If this is smaller than this, the inequality flips. How do we find that? You have to just put this in the power to any number. Say, for example, I'll just consider 1 minus 5. What is the answer? It is 0.004. Now I will do the same thing over here at the right side. 5 to the power 3 into 1. Now this is bigger. The second value is bigger, isn't it? The second side. So you basically flip. It's not the same. You don't write like this. You flip it. Whereas if this was a bigger number, if this was 100 and this was 20, then y less than the answer. So this is how it works for inequalities. You can solve it by calculator, but it confuses most of the students. If you have understood it, well and good. But if you have not understood it, don't worry. Please do the method over here. It's only for this inequality problems, right? So only for the inequality, take log on both the sides, use distributive property, and then keep log at one side and keep y's at one side, all the y's at one side, and remove the y common out, and this take it to the other side and solve. You will get y. You will get this answer as negative 7.19 is less than y, or y is greater than the answer. This is it. This is how we solve inequality problem. And checking is not so much required, but you can just put a random x value over here, and it must be this inequality must stay true. Yes, it will obviously, if you have done it properly, it will stay true. So this is the answer. I mean, with the y value. Okay, that's the thing. Check is not required. Find the answer. If you have understood this, it is more than enough, because in the exam you don't have enough time to properly write the answers. So check. If you have plenty of time, yes, you can do it. Now, change of base. This is another interesting topic and one of the important topics, because if you don't have a scientific calculator with different base option, then change of base is very, very important. But your calculator, most of your calculator do have the base option. If it is not there, what to do? Now imagine I have, okay, there's an example over here, log 8 and log 17, right? I can write this with any logs of the same base, but then the catch is, see over here, whatever is outside will be up, divided by the base will be at the denominator. Here, just make sure you write same base, 10 10 or 5 5. Even this is same. You can try this. I will just show you over here, log base 5 and I have 17, and over here log base 5 I have 8. Okay, the answer is 1.362. Now let's do this one. Log 8 17, the answer is 1.362. It's the same. Let me change, this will be the same answer, it won't change. Let me change this base now. Here, let me take the base as 10 and 17 and divided by log base 10 of 8. It'll be the same answer. As long as the bases are same, this is the thing. So, very important, very important thing to remember, the log bases, when you're changing the base, see, because base 8, it is very hard to find if you don't have proper model of scientific calculator. So what you can do is, whatever is this number, if I have log 10 and base was 5, then it's fine. I can solve this as log, numerator as the term over here 10, and denominator as the base value 5. And if it's just log, it's common log, base 10, base 10. That is how we will solve. Now we will see some problems here. Here you should evaluate log 2 of 11. How do you do it? Log, let's take the common logarithm, that is base 10. First will be 11 divided by log 2. This is the change of base. You can see now here it's mentioned 10, but you don't need to mention 10 every now and then, because you know it is log 11 divided by log 2, close the bracket, 3.4594. Even instead of log, you can use LAN, natural logarithm. See this, and you will get the same answer, because both natural logarithm is also log itself, just the base is e. In both the cases it's e, so you can do it. Otherwise you can check your answer directly, log base 2 and 11. That's the answer. Same way, please do try this by yourselves. Just use your calculator so that you'll be quick when you solve it in your exam. This is how we solve it up. And now then we will go to a real world problem. The musical cent is a unit of relative pitch. One octave consists of 1200 cents. The formula to determine the difference in cents between two notes with the beginning frequency A and ending frequency B is given over here. Log is being used. So this is the difference of n cents. Find the frequency of pitch A. A we need to find if B is given. Okay, this is the frequency of B. And the difference of pitches are given. N is also given. What is N? 1600 cents. So everything is given, guys. This is, sorry, B, N. Substitute over here. N is 1600 equals 1200 log base 2. A is what? A is unknown. That is what we are finding. B is 1161.22. Close the bracket. Now here you can directly use your calculator and solve, or you can use change of base and even solve it. It's up to you. Let me just try directly over here. I hope you know, because we have solved problems in the long method just now, so you can use that methods as well. Here it is log base 2, and what do you have? A is unknown, so I'll write x divided by B value is 1661.22. And close the bracket, shift and solve. Okay, now, okay, there is problems with the brackets. Let me see, shift and solve. Syntax error. Okay, let me check. Where did I do it? Okay, I understood what they mean. Whenever you press on log, no, is it? Okay, let me just close the bracket over here. Okay, I understood what it meant. I will tell you now in a while. Let's just check the answer. The answer is yes, this is the correct answer. Now, why I was getting syntax error, that was because, see, when I use log of base, can you see this option? Automatically, it opens up a bracket. Okay, so you need to write what was A is unknown, and the frequency of A is 1661. Sorry, I should go down, 1661.22. It's a good mistake to do. Now here, I close the bracket over here. That means it's an error, because this is already inbuilt bracket. Go out and now close the bracket, shift and solve, you will get the answer. Okay, whereas if I close the bracket inside this, it doesn't allow it because it's wrong. I hope this is clear. So this is where you should go outside and then close the bracket and then shift and solve. You'll get the answer 4186.01. Or you can do the steps over here, just 4 steps. It's simple as well, and solve it. Last problem, over here. The revenue of a company R is equal to R equals 227 plus 44 log base 5x, where R is the annual revenue of the company in thousands and X is the amount spent in advertising in thousands. Okay, so revenue depends on advertisement, because the more you advertise, the more people come to know about your business, and then you will get more business. Use a graphing calculator to determine the amount spent on advertising if the revenue of the company is so much. So this is the relation where revenue and advertisement are related. Now here they have given you the revenue is $325,000. How much did they spend on advertising? So R is 325. Remember, this is all in terms of thousands, so don't write 000, just write 325 equals 227. In terms of thousand means now 325,000, right? I just write 325. This is 227,000, but I just write 227. And 44 log 5x. Just use your calculator directly and you can get the answer. It is 325 equals 227 plus 44 log base 5, and over here alpha x unknown. Shift and solve, you will get the answer to be 36.040 over here. Now this is in terms of thousand, so after you approximate, just make sure you write 36,041. So that's the answer. If you're thinking how to solve this by writing, you can just take this to the other side. 325 minus 227, it'll be 98. 227. Okay, yeah, it'll be 98, I believe. Somehow my mind is now working properly now. Yeah, hopefully. Now then we equal to 44 log 5x, isn't it? So now divide both the sides by 44. Take this 44 over here, so that's gone. Now here you can just change the base. That means you can do log x divided by log 5. And then you can take this to the other side and then solve, because log can be solved, isn't it? Or you can even convert to exponential or any method, It's just that they have asked you to change the base, right? That is the concept over here. But you can directly do as well. If it's MCQs, you can just do the calculator. Even if you're doing change of base for log, you will have to use the calculator, because otherwise it's a log table book which is not used. So you need to use this option over here. So that's how you solve these problems about common logarithm. It's very simple. Common logarithm is log with base 10. And we don't write the base always. We just understand that if there is no base for a log function, it is understood to be base 10. So I hope you found it useful. And please do stay tuned. I will upload the other lessons as soon as possible. Bye-bye for now.